Okay, welcome to the brand new unit in geometry. This is Unit 7, and this is a section about quadrilaterals and coordinate algebra. So what we're going to do in Section 1 is we're going to classify quadrilaterals. Now, a quadrilateral is a polygon with 4 sides. Okay, typically we've been working with triangles with 3 sides, but we're going to be dealing with quadrilaterals. Now, the quadrilateral is a generic term for any 4-sided figure. Okay, and we can break that up into 3 different sections, okay, of a trapezoid, a parallelogram, a kite, and then we'll really focus on parallelograms because that's how we get rectangles, a rhombus, and the most special one, a square, okay? So when we talk about these, all right, what we'll do, and let's kind of take a look at this. A trapezoid is a quadrilateral with exactly one pair of parallel opposite sides. Okay, so up here when you see the trapezoid up here, okay, you may want to write in that all you see here are 2 pairs of parallel sides. Okay, kind of hard to write on that small part there, but that'll be all right. Okay, a parallelogram is a quadrilateral in which 2 pairs, both pairs of opposite sides are parallel. So what I know about a parallelogram is that these opposite sides are parallel and that these opposite sides are parallel. Okay? And a kite is a quadrilateral whose 2 pairs of adjacent sides are congruent and whose opposite sides are not congruent. So what I know about a kite is that these 2 segments are congruent and these 2 segments are congruent. Okay. A rectangle is a parallelogram with 4 right angles. So a rectangle is a parallelogram. So its opposite sides are going to be parallel to each other, but I know that it has 4 right angles, which is kind of unique about a rectangle. Most times we live inside rectangles. They are the rooms and the hallways in which we utilize in a building. Okay, a rhombus is a parallelogram with 4 congruent sides. So a rhombus doesn't have right angles, but all sides are congruent. Okay, and a square is something with all 4 sides are congruent and you have 4 right angles. Okay, so we're just classifying these. Okay. And so that's all we're doing, all right? So let's think about something in the real world, okay? Selma wants to build a garden shaped like a kite, and she has logs for the edging, so for the outside for her garden. 3 logs measure 6 feet, and 1 of the logs measures 9 feet, and 1 measures 3 feet. So can Selma build a kite-shaped border with these logs without cutting them? And so, what you think about is you have, 3 logs that are 6 feet. So I'm going to do this. Let me make a log like this that's 6 feet, 6 feet, and 6 feet. We have one that's 9 feet. Okay, and then we have one that is 3 feet. Okay. Now what I know is that I have 2 logs that are already congruent. So what I'm going to do is this. I'm going to draw this like so and say that this is like, say, a 6-foot log. Okay, I'm going to put those 2 right here at 6 feet. Okay, and then I have this 9-foot log. That's like this. Okay, and that's 9 feet. All right, now if I look at my other logs, I have a 6-foot log and a 3-foot log. So I could add in this 6-foot log right here, okay? And then I could also add in this 3-foot log so that the whole thing is 9 feet, okay? And that's kind of the idea, all right? We just want to make it look like the shapes we have up here, all right? Another important thing about talking about quadrilaterals is the sum of the angle measures in a quadrilateral. So what we know in a rectangle right here is that all of the angles are 90 degrees, okay? And so if I were to take 90 degrees and multiply it by 4, okay, it's going to give me a total of 360 degrees, okay? So that's what happens in a rectangle, okay? Now the cool thing is that when we do this, all right, we can also extend that to any quadrilateral, all right? So if I take any 4 angles in a quadrilateral, the angles will add up to 360 degrees. And so we have that here, okay? Quadrilateral angle sum theorem, the sum of angle measures in a quadrilateral is 360 degrees. So if I were to take angle A plus angle B plus angle C plus angle D, if I add all those up, it's going to give me 360 degrees. So much like when we had a triangle, when all those angle measures added up to 180, in a quadrilateral, they add up to 360, okay? And even if, an example over here, if you took angle D plus angle E plus angle F plus angle G, those would too also add to 360 degrees, okay? So let's apply this idea, and let's just say we have this thing here, okay? So we have this quadrilateral, and it says the front view of a recycle bin is shaped like a trapezoid, okay? And remember, a trapezoid is something where you have 2 parallel sides, okay? And it says, what is the measure of the remaining angle? Okay, so I'm going to call this just x degrees. All right, so what I would do is I would take 72 plus 108 plus 108 plus x degrees. Add all these angles up, and then I would set that equal to 360. Okay, so let's kind of combine like terms here real quick. Let's do 72 plus 108 plus 108. So 72 plus 108 plus 108. It's going to give me 288, okay, and that's by adding all 3 of these numbers up, okay, and I add x to that, and that's going to give me 360. So then I'm going to subtract 288 from both sides, okay, and that's going to give me that x is equal to 72 degrees, okay. And it's kind of unique because, you know, we have that same angle measure over here, so we'll explore how we know, you know, we could, at the end of this unit, we'll be able to kind of look at this picture and just know that that's 72 based off of a couple facts, okay? All right, so now let's take a look at a problem like this, okay? Find the angle measure of this kite, ABCD, okay? Now what they did is they went ahead and they gave us all these different angle measures, okay? And so we need to find what angle A is, okay? We need to find out what angle B is. We need to find out what angle C is, and we need to find out what angle D is, all right? Now, in order to figure that out, we have to solve for x, okay? And so what I would typically do is I would take all these angles and add them up to 360. So, and it looks like we've already done that, okay, on these notes. We've kind of already set up this equation where we take all these values, add them up, and get 360 degrees, okay? And then what we want to do, let's take this equation and let's solve it for x. I'm going to zoom in here. All right, so let's combine all of our like terms, okay? 4x plus 6x gives me 10x, plus another 3x is 13x, plus another 5x is going to give me 18x. So I've got 18x, okay? And then if I take 13 minus 16, that's going to give me negative 3. Subtract another 1, that's going to give me negative 4. And then add 4 to that, it's going to give me 0. All right, so I just got 18x is equal to 360 degrees. So I want to divide by 18 on both sides to solve for x. So if I take 360 and divide that by 18, that's going to give me an x value of 20, all right? So we're not done, okay? We still have to find all the angle measures over here, okay? So let me do some work down here. Let's first take a look at angle A. Okay, so angle A is equal to 4 times x plus 13. Okay. Now I'm going to substitute 20 in for x, and so I get that angle A is equal to 4 times 20 plus 13. Okay, so angle A is equal to 80 plus 13, so it ends up going to give you 93 degrees. Okay, so I'm going to write that over here, that angle A is 93 degrees. All right, now let's take a look at angle B. All right, and I'm going to use a different color for that. So angle B, and that's 6x minus 16. So 6x minus 16. So let's plug in 20 in for x. So I've got 6 times 20 minus 16. 6 times 20 is going to give us 120. And then if we subtract off 16, then angle B is going to give me 104 degrees. Okay, so there's that. All right, now let's come back over here and let's write that in. That angle B is 104 degrees. All right, let's take a look at angle C. Okay, angle C, we'll do that one down here. And so angle C was 3x minus 1. Okay, if I plug in 20 into that, okay, angle C is going to give me 3 times 20 and then minus 1. So angle C is going to give me 60 minus 1, which gives me 59. So angle C is equal to 59 degrees. All right, and so then come back over here. Let's write that angle C is 59 degrees. I'm going to bet that angle D is 104, but that's just me. Okay, so let's try that. Let's check and see what we get here on that. And so let's do angle D is equal to 5x plus 4. Oh, yeah. Angle D, all right, 5x plus 4. 5 times 20, plug in 20 for x, and then add 4 to that. 5 times 20 is 100. And then add 4. Okay? So then we know that angle D is equal to 104 degrees. Okay? And so that's kind of interesting. I already said that I said I would bet that that's going to be 104. Okay? Now the reason is because when you take these two opposite angles here in a kite, those angles are congruent. Okay? And that's just one of the properties. So, you know, it'll get to a point, guys, where we'll take a look at this and we'll just be able to, you know, take a look at a picture, know that it's a kite, and we'll know all sorts of information. So this is kind of just an overview of these two sections, but what I want to do just kind of show you how these angle measures work, and we'll go into more detail at a later date. So thanks. Bye.